Hi everyone, we are Team The Blacklist. So today we're going to talk about academic success. As students, grades matter to us a lot. So we are trying to investigate what factors affect grades. Our data is obtained from two secondary schools in Portugal. It contains both school records and questionnaire results from students. So the data actually contains two separate data sets, one from the math course and the other from the Portuguese course, with 382 overlaps and 33 variables. The people who collected the data, Cortez and Silva, in fact have also conducted analysis themselves. And the conclusion they drew is simply that students' achievements as in their final grades are highly influenced by their past performances, which is more like a common sense and not a very good use of the data. And in our investigation, we'll attempt to explore the relationship of final grades with a variety of variables. And here's what we found after the exploratory data analysis. So the first variable that captures our attention is a binary categorical variable that tells us whether a student plans for higher education or not. And it turns out that, in general, students who do have higher grades than students who don't. A more interesting thing is that students who obtain the top 20% final grades all plan for higher education. And after we converted the numerical final grades into categorical passes or fails, the effect becomes more obvious. So in the math data set, students who do have a pass rate of 68, whereas students who don't is only 35%. And similarly, in the Portuguese data set, students who do have a pass rate of 88, whereas students who don't have a pass rate of 52. And next, another interesting variable that we found is a discrete numerical variable called mother education level, from a scale of 1 to 5, with 5 being the highest. And now let's take a look at this graph. So the blue line here highlights the third quartile for the final grades, and what that means is that every point above that line represents a student who get a final grade that's in the top 25% range. And as we can see, as matter education goes up, we have more students in the top 25% range. And now let's move on to the next variable, internet access at home, another binary categorical variable. It appears that having internet access at home have a minor boosting effect on students' final grades. As we can see, the mean final grades for the internet access yes group is 10.6, while that for the no group is 9.4. And now for the bar graph. After we converted the final grades into passes and fails, we found that in the math data set, students who have internet access have a pass rate of 68, whereas students who don't is 60%. And similarly, in the Portuguese data set, students who do have a pass rate of 86, while students who don't have a pass rate of 78. And last but not least, number of past class failures also seem to have an influence on final grades. So the blue line here indicates the average final grades, and we can see that as number of failures increases, less students get grade above average. And when failure is at 3, and 3 here actually represents having 3 or more failed classes, not a single student get grades above average. And now let's move on to the model tuning and fitting part. So in this page we can see two tables, and the tables summarize the precision of 6 models for each level of final grades, namely passes and fails. And for each data set, the baseline is drawn by the actual proportion of this level in the data set. For instance, there are 67% of students passing the math courses. So if we blindly classify all students as pass, we will still get a precision of 0.67 in predicting students' final grades in math courses. And as we can tell from the table, even the worst performance by random forest have a precision of 0.69, and the classifier is still doing better than blind classifying. So according to the two tables, all the precisions of the models are above the baseline, and these two tables are crucial since the two data sets are imbalanced, and accuracy as well be covered in the next slide is not sufficient to show the performance of the classifiers. So next, we can see that this table summarizes the accuracy of each model for each dataset, and the accuracy estimates are given by a 5-fold cross-validation over the whole dataset. And as we can see in row-wise, support vector machine (SVM) performs the best in math cases, and random forest performs the best in Portuguese case. So the three methods all perform better in the Portuguese case, which is reasonable since the training data set for the Portuguese data is almost twice the size for the math data set. And this will allow the model to learn better. And that will be all. Thank you.